And welcome back to New Space Age Conference. We're about to start the Innovative Launch Technologies panel. Just with launch systems becoming, having progressed so much in the past years, we see a lot of reducing launch costs, increasing the frequency of launches, and definitely improving reliability by a lot. So in this panel, we'll dive into how these companies are continuing this momentum, creating different competitive edges to meet the growth of this launch demand. So it is my pleasure to introduce our esteemed moderator for this panel, Dr. Hans Koenigsmann. Hans joined the SpaceX team as the 4th technical member in 2002. And as the vice president of avionics, he developed the avionics guidance and control and software departments. He later moved into an operational role as vice president of flight reliability, responsible for flight risk and safety, resolving critical anomalies, and supporting more than 100 launches. And after more than 19 decorated years as a critical leader at SpaceX, he retired in 2021. He holds a master's from the Technical University of Berlin and a PhD from the University of Bremen in Germany. He currently serves on the supervisory board of OHB and advises Stoke Space, Vast Space, and Varda. So with that, I'll introduce Hans Koenigsmann and the rest of the panel.
All right. Good afternoon. I was going to mention that the launch panel is on the minute, on the second actually. We just wait for the audience to be ready. But anyways, we have 4, I guess, launch startup, partly startup companies on this panel. And I thought the best thing is if everybody introduces themselves. And we're going to start with you, Devin.
Sure. My name is Devin Papandrew. I'm the VP of Business Development at Stoke Space. Stoke is working on a 100% reusable 2-stage medium-lift launch vehicle. We've raised about $220 million so far. We've done a vertical takeoff, vertical landing hop test of our full-scale reusable upper stage prototype. And we're continuing to build hardware and approach our first launch.
I'm J.R. Francis, Director of Business Development at Relativity Space. For those of you who don't know, Relativity is developing a medium-lift launch vehicle called Terran R. Look forward to the discussion.
And I'm Jordan Charles. I'm the Vice President and General Manager of the New Glenn Stage 1 Reusable Booster Program at Blue Origin. Blue Origin, we're focused on a variety of different things, but New Glenn very much is intended to be a very large orbital heavy lift launch vehicle. And just as a side note, first off, thank you for having all of us. I was talking to some of the organizers of this conference earlier. I had the privilege of helping organize this conference 7 years ago in its second iteration, and I will say it was very much a question mark whether this conference would make it back then. So super proud of the legacy and the fact that this has really become a preeminent gathering for the new space industry.
And I'm Megan Roth, Senior Director of Launch Integration and Test from Firefly Aerospace, primarily focusing on launch vehicles. So that's A330, which is our medium lift launch vehicle, as well as Alpha, which is our small launch vehicle.
Thank you. And I'm not sure you caught all of this, but we not only have 4 different companies, we also have 3 different parts of how launchers are being, I guess, they're going to be manufactured, right, on one side, and then they're going to be tested and launched, and then there's also business development. So we got all these areas covered up here. That's pretty good. I got a couple of questions, obviously. I'm going to start with one that basically is the vision question. Space is pretty hard, and the rocket part is actually the hardest part, in my opinion. Probably debatable, but you need inspiration for that. You need a special mission. You need to have a mission and a vision for the people that work on this and for the company. And I want to ask basically what is your company's mission? What's your vision? I want to start with Megan on this one and then go over here.
So I cut my introduction a little short because I didn't want y'all to have to hear me repeat myself. because I knew what the question was, so thank you, Hans. So Firefly's, I feel like I keep talking away from the mic, I'm sorry. Firefly's differentiating stance in the market is that we are an end-to-end space transport company. So essentially, if you want to do it anytime, anywhere, we're there to serve you, be it LEO, GEO, cislunar, or anything else. So what I mean by that is, while my primary focus is in launch vehicles, and what you can see behind me is actually as part of our console, I've been the LC and LD for all of our missions so far, and will be for the rest of the missions this year. So very, very intimately tied with launch. But we also do an in-space vehicle transport called Elytra, as well as a Blue Ghost mission, which we're sending to the moon in the end of this year. So part of what differentiates Firefly is our ability to not just launch a vehicle, not just move vehicles in space, and not just go to the moon, but to do all of it and to combine those services in a way that lets you pick and choose what it is that you want access to.
Right, Howard.
Yeah, for Blue Origin, our vision and mission is to enable a future where millions of people are living and working in space for the benefit of the Earth. And it's for the benefit of the Earth. I think that's the super critical part of our mission and vision statement. Obviously, Earth has finite resources, and the trajectory that we are on as a human species is not sustainable to keep us growing at the rate that we're currently growing. And unless we are able to take humanity and expand humanity's reach beyond Earth, we will at some point in time reach a point of stasis, so as a species. And so our vision is really all about enabling the infrastructure required to move the human experience beyond Earth. And I'd say that's a common vision probably amongst many of our companies on the stage here. We have 3 gates to enable that vision. The one that we're most focused on right now is radical launch cost reduction. Earth's gravity well is a pain in the ass. And it's very hard to escape. And so, obviously trying to figure out how to do that efficiently and cheaply is a core part of our vision. In addition to that, our second key gate is figuring out how to utilize in-space resources. So we do have teams of people at Blue Origin that are beginning to look at that challenge, starting with the moon, obviously, as a partner to NASA in the Sustaining Lunar Development contract space. And then the third pillar, probably my favorite pillar, is inspire the next generation. This audacious vision statement that we have as a company is not something that's enabled in our lifetimes. And so we have a nonprofit at Blue Origin called Club for the Future that is really, its goal is to improve access to STEM for underserved communities, to bring STEM to the forefront for the next generation. And so the majority of people at Blue Origin are deeply embedded and highly passionate about what Club for the Future is trying to do and are key ambassadors. So the mission statement really is enabled by those 3 pillars.
All right.
Yeah, I agree. Like in our industry, space is very hard, and I think it's super important to have a long-term vision to attract and retain some of the best engineers in the world. And so at Relativity, building out the industrial base in Mars has always been our long-term vision, our North Star since the company was founded almost a decade ago, and that remains a critical part of our DNA today. But I will say, if we zoom in a little bit, our short-term goal, and one that the entire team is laser focused on a day-to-day basis, is bringing Terran R online as quickly as we can, as we see that there's a very large supply-demand gap in launch right now.
Yeah, I think similar to my colleagues here, our vision at Stoke is to build space infrastructure to help scale the space economy, to seamlessly connect Earth and space. And the way that Stoke fits into that, at least initially off the bat, is radically increasing access to and from space. I think our vision is to enable aircraft-like operation, routine logistics, bringing cargo and satellites to and from space. I think that is obviously the crux of why we're all here. Yeah.
All right, thank you very much. I mean, given how hard it is, there's an amazing amount of companies working on that right now. There's also I guess, legacy companies that have been doing this for, some of them more than 20 years, some of them for 10 years, something like that. So as contested as the market is, how do you distinguish yourself from, I guess, both the legacy and the up and coming space launch competitors? And let's start on Devin on this time?
Yeah, there are a lot of launch companies out there, a lot of competition. Our thesis, sort of our founding thesis at Stoke, is if you want to be successful, you have to think about the end game before anything else and then work backwards. And that end game, I'm convinced, in launch is routine logistics going to and from space with fully reusable vehicles. And so our way of differentiation is to design a vehicle that from the outset is built for that rapid, high cadence, fully reusable operation. It's one thing to recover an orbital upper stage, bring it back, and eventually fly it again. Right? That's been done with shuttle, for instance. That's a big challenge in and of itself. But what's actually more important than just being reusable is being what we call rapidly or operationally reusable. And that means something that can fly like a 737, where it's land, refit, refuel, and refly in a very quick turnaround. That means minimal or no refurbishment between flights. So we have to think really hard about all the things we're not doing in between each flight. As an example, and perhaps the most visible example, we've chosen to use an actively cooled reentry heat shield. Obviously, you need to protect an orbital upper stage from the heat of atmospheric reentry. And this heat shield is integrated with our upper stage engine. The engine and the heat shield are one and the same. And the big benefit of that is, as an industry, we've actively cooled engines for decades, and they've been robust and resilient to damage, bird strikes, ice strikes, foam strikes, a technician dropping a wrench. These are all things that have happened in real life. So that's the main one, and there are a few architectural decisions that we've made that we think are the right approach for climbing this right mountain, and the right mountain is full and rapid reuse.
Yeah, I think similar to Devin. I think I mentioned it before. We see a huge demand for medium to large launch vehicle demand. And we feel that Terran R is positioned pretty well from a product market standpoint to bridge that gap and fill some of that demand. So I think we feel that we feel like we have the right product. Now we have to obviously bring it to market. And I think one of the things that we're focused on is our iterative way that we design, test, and build, which we proved out with the Terran 1 development program, and it's paying dividends now for the Terran R program. I think the best example of that is our mission duty cycle test that we did for ANR, which is the engine that's powering Terran R. We completed that MDC test late last year. And that engine went from initial design to hot fire test in less than 2 years, and then from first hot fire to full MDC in 2 days. And so that really shows the ability for us to scale rapidly and leverage the design, leverage some of the lessons learned from Terran 1 program. And I think it gives us the confidence to not only have the right product market fit, but be able to deliver it to the market on time.
Yeah, from our perspective, we, our founder very much believes that rockets scale really, really well. And so we started big with New Glenn. New Glenn is a heavy lift, reusable launch system. Obviously, reusability key to enabling that lower cost access to space. But when you look at our payload fairing, for example, we have one of the largest payload fairings ever developed at 7 meters in diameter, and that positions us very nicely for pretty much all the existing customers and customer base that's out there, as well as expands the envelope for new customers and new capabilities. Just being able to transport something of that size into space, and so that's really where we're trying to enter the market with New Glenn at scale, I would say, is one of our key differentiators. The scale of New Glenn is quite large. It's a very ambitious undertaking for our first orbital launch vehicle for Blue.
I think our differentiator is probably, and something we've leaned into, is responsive space. And so you can imagine if you were to make a call and you order something online, you don't want to wait until the right UPS truck gets there and the right thing is delivered to you. You want to be responsive and you want it now. And so I think, to just echo, one of the best examples of this for us has obviously been the Victus Nox mission that we launched the end of last year. So Victus Nox was a 24-hour call-up. So satellite made 2 on orbit and verified in less than 24 hours. And so the interesting thing for that was not only proving out that the operations that our team could do, so both payload integration, payload mate, vehicle loading, launch itself, and then acquisition of signal, but also what it took to coordinate with range resources and other sources around the world and kind of push this bar and push the envelope for saying, no, this is where we're going, This is how we're going to do it, and we have to do it responsibly and in coordination with not just us, ourselves, but also mission partners. So I think that's something that we were really excited to prove on the third launch ever of Alpha, that we could be responsive and break the record by 21x. It's also something that we've leaned into with our orbital transfer vehicle Elytra, as well as our own repeated history of responsive space. So both Flight 4 as well as our next Flight 4 missions we've committed to doing in less than 24 hours from payload mate to launch. And so far, so good.
And I just want to add to this too. I mean, just getting to orbit is such a hard thing to do. And then of course, competition makes it even harder, right? So, but the accomplishment of just what you guys are doing overall, all of you, is pretty amazing to launch something. Anyways, but we talked about market too, right? I think, JR, you mentioned that, yeah? And then the question is a little bit like, how big is that market? Does the market grow with the launchers? What changes do you expect in the next 10 years? And how fast is that market growing? Is it growing as fast as you guys developing the vehicles for that?
Yeah, I mean, I think obviously, based on my comments before, I think we're very bullish on the market. I think there's significant demand for medium to heavy lift launch. And I think, that's driven by three different areas. I think primarily it's the constellations, both deployment and repopulation, as well as the direct-to-device connectivity market, as well as global government demand. And I think we can debate we can all debate whether who's going to fill that demand or who's going to fulfill the supply or the demand. But I think the two parts that we can be certain of that will change over the next 10 years will be increased demand based on those three areas, and that there will be some new entrants in the launch market to fulfill that demand. Again, I think you can debate the who and where and when, but I do think that we're going to see significant growth in the market, both from a supply and a demand perspective over the next 10 years.
Yeah, agree fully on the market outlook. Our backlog right now for New Glenn is massive. With the very large LEO constellations that require significant initial deployment and replenishment, and even things like the lunar SLD contract, we have a need for a ton of launches just to be able to refuel and get propellant into orbit for that lunar program. That requires a lot of launches. So, historic amount of backlog for New Glenn, and I think just as our companies are able to all collectively succeed, we will enable that lower cost reduction that we're all trying to enable. And that will just invite more entrepreneurs and more applications to join, and it's a vicious cycle, a self-reinforcing loop, if you will, of sustained business for all of us.
Mm-hmm. As we said earlier, there's a whole variety of people up here, and I'll just go ahead and say I'm not the biz dev person, but I will answer the part of the question that came with how will things change in the next 10 years. I think one of the things that we've seen internally at Firefly as well as externally is the demand for multiple services from your contractors. And so when you're working with somebody, not just having access to a vehicle in this one particular ride, in this one particular orbit, but how do you manage to group satellites together? How do you lower the cost to consumers by doing things like that? How do you allow them to get into certain orbits that maybe your vehicle can hit and then move them in space with an orbital transfer vehicle? Or how can you use multiple transfer stages like we're using on our BGM-2 mission, which just passed CDR, which was exciting, to do additional things in space? So I think what you're going to see moving forward, and the differentiation is the market is not just paying for a transport to an orbit, but these bits and pieces and how they go to play together. So how could I construct what I'm looking to do for my payload from different providers and different service aspects of the market?
Yeah, I think to your point, Megan, a lot more customers are going to start to demand really access directly to their final operational orbit. And there's a few different ways we'll probably all go about doing that, but I think that will become more and more the expectation, the norm rather than the exception, as there are going to be more launch opportunities to meet demand that is currently very supply constrained. I think as we think about the market, right, we learned from Alex at Starfish this morning that we don't like to call them mega constellations, it's large constellations. But there's those large constellations that need to get on orbit and they just don't have a lot of options today. I think we're going to all address that. I also am really excited about the CLDs, the commercial LEO destinations. I think those are going to need actually a lot more launch than many people are thinking about today. if they're going to be crewed or uncrewed or manufacturing a lot of things for Earth. There's a lot of things that can be manufactured in microgravity, which is really interesting. They'll need up mass of raw materials and down mass of finished goods at a very high cadence, and they'll really want to scale. So I think there's just a lot more demand. Telecom is a huge part of it, but it's not the only part of it. And I see that growing really substantially over the next 10 years.
Yeah, you mentioned the CLDs, or commercial LEO destination, but basically I think it's just a word for space stations, right?
Space stations.
Commercial space stations. So at the end of the day, space stations needs astronauts to go up and down, and needs cargo to go up and down, food, clothing, water, everything basically, and so I see that part definitely on the side too. But part of what enables that is actually cost, right? And cost is somewhat connected to, not totally, but connected to reusability. And my understanding is this is a requirement for all or most of you. But I want to know a little bit more what your take on that is, implications, and what it actually means for your company. I want to start with Jordan from Blue at this for this question.
Yeah, reusability. I have the privilege of leading the element of New Glenn that is reusable, we out of the gates on the initial design concepts, all the way through our design cycle, through CDR, now into final integration. Reusability has been at the core of everything that we've been trying to do on the first stage of New Glenn. It is deeply embedded in the design DNA. It is deeply considered in how we test our hardware, how we validate and verify our hardware. It's not just reusability, but I think, as JR, you put it, operational reusability, where the system has to be highly refurbishable. It has to be able to be turned around very quickly. All of that has been deeply embedded into our design DNA. When you talk about key technology enablers of reusability, things like thermal protection system of your system to enable your system to withstand the heating of reentry. We employ a proprietary thermal protection system on our first stage of New Glenn that is built for robustness and built for serviceability. Our strake and fin architecture on the first stage is really intended to kind of mimic that or achieve that high level of L/D flight profiles and trajectories to limit the amount of reentry heating, to limit the amount of restart engine burn fuel that you require as you're coming in. So the entire architecture of our first stage is really built around that operational reusability principle. And even how we test all of our components, we cycle them many, many, many times to mimic the many mission duty cycles that we need those components to survive in order for a vehicle to be highly serviceable, such that we're not having to pull components between missions very frequently. So it's embedded in our DNA.
So I think we're probably on the other end of the scale. I think we're the only ones not claiming reusability right now at Firefly. And so especially if you were part of the early small launchers, kind of the race, that first generation that was going forward, there was certainly this push to make it to market first. And so there was definitely a push at Firefly to make it to market first, which drove us for single use, among many other things. But one of the interesting things from that is now that we have kind of established our presence, we have partnerships with Northrop, we are additionally looking into reusability when it comes to the medium launch vehicle, so the entire that side of the program. I think it's one of those things that, as you've seen with New Glenn, as you've seen or upcoming with New Glenn, as you've seen at SpaceX, as you've seen with other markets, there's no denying what a difference it makes to a business case to be able to use something 10x, right? But the other thing of that is, especially when you're a startup and you are funding from VC and any additional funding will go ahead and lower the value of your shares. There's only so much testing and so much operations and so much development of the perfect component that can do 10x life cycles. So I think there's a give and take when it comes to being able to do that, and there's a reality of what it takes for funding. There's a reality of what it takes for funding if you have certain backers or you have certain other backers if you're part of the VC world. And so Alpha is not currently reusable, but we do have intentions of going that direction when it comes to our larger vehicle.
Yeah, I think if we want to reduce costs to service CLDs or do anything, the most powerful knob we can turn is flight rate. When you ramp up your flight rate, you have many, many more revenue-generating events per year across which you can amortize your huge fixed overhead, which we all have. And that's our reason behind going after full reusability. Obviously, it's very beneficial to use hardware 10x. That definitely helps. But what we don't want to be doing is sitting on the ground waiting for the next flight because we're building an upper stage or we're building other flight hardware. So that drove our decision to go after something that is rapidly and robustly and fully reusable, right? Such that we can fly to orbit, deliver a payload, recover and return both stages, and then quickly turn them around to fly again. And once we're out of that production limited paradigm, where in that paradigm, if you have to build a new vehicle, if you want to reduce costs, the two things you can do are try to improve your ISP or improve your mass fraction, which I think asymptotically we're all doing. But if we want that step change, what Falcon has shown with partial reusability, we believe we have to go after the fully reusable solution.
Yeah.
Yep. Yeah, I can be short and sweet. Totally agree on reusability. Terran R is designed out of the gate to be you have first stage reuse, and we think that is key to the ability to scale and unit economics that has given Terran R the product market fit that we feel today.
Yeah, one thing that I noticed, reusability it does lower the cost, but it also makes the entrance cost for any new rocket so much harder because now you have to build a rocket that does both, right? Otherwise you're struggling in the long run, basically. And so obviously that is an interesting development that I did not personally, foresee, but is now basically a reality that reusable rockets are there, and competitors have to deal with that one way or the others, right? So that's going to be very interesting. Anyways, is there anything in the next 6 months, 1 year coming up for your companies that you can tell us about and that we can watch on the webcast or something? Anything exciting? Let's start with you.
So just last night we installed our stage 1 engine on the test stand in anticipation of pretty imminent test firing of the stage 1 engine. So stage 1 is powered by 7 engines. They're full flow stage combustion, liquefied natural gas, liquid oxygen engines. We chose to do full flow stage combustion, which is it is a complex engine cycle. Really only this engine and Raptor are the two really active or in development. But it is the right engine cycle for something that we want to fly over and over and over. It can operate at lower temperatures and lower pressures and still get high performance. And you need minimal refurbishment, which is very aligned with our thesis. So I hope that happens very soon in the next 6 months. We'll be hot firing that engine.
And you're going to give us a webcast for that too, or?
We'll definitely share pictures and video. I don't know if we'll have a live webcast, because as with any engine development, there's going to be a lot of starts and stops and making sure we're doing things the right way, doing stand activation, all those things. But we'll definitely share that. That's really exciting. And then soon we'll be breaking ground on our new launch site down at the Cape.
Yeah, at Relativity, I think you'll continue to see over the next 6 months of a bunch of engine testing coming online. But I think the key thing that you will see from us over the next 6 months is really the investment in the infrastructure, as Hans mentioned, to bring, and Jordan knows as well, and everyone on the panel knows that in order to bring a rocket online and have it be reusable, you have to invest in the infrastructure prior to it coming on. So that's what we're doing. You'll see massive infrastructure upgrades at Stennis, where we do with the engine testing. That'll lead to the qualification and acceptance testing of our ANR engine, as well as first and second stage testing. That infrastructure upgrade's ongoing. And we also broke ground on the new launch site at Launch Complex 16, which is the same launch site that we launched Terran 1 from. So 2 pretty big infrastructure upgrade projects going on in parallel. And then we're also continuing to build up our major factory, our main factory, I should say, in Long Beach that does the engine production and the structures. That's ongoing as well. And certainly, last but not least, to continue to build out our commercial backlog as well.
You have a tentative date for launch or for the maiden launch?
Yeah, we're targeting 2026.
26, okay.
And then for New Glenn, this is our flagship year. 2024 is the year that we will attempt our first flight, and we're off to a really fantastic start this year. In late February, we successfully completed an integrated tanking test campaign with cryogenics at Launch Complex 36. And that really exercise, I was with flight hardware. It was with our first stage, first flight tank. And it fully exercised our end-to-end manufacturing and launch operations flow, basically all the way through tanking complete. And anybody that knows anything about that process, that's not an easy thing to do. So getting that behind us with a full stack integrated launch vehicle was an absolutely critical, huge milestone in our path to first flight later this year. And we're just very, very excited for getting New Glenn off the ground.
It's just to jump in there. People think it's easy to tank a car, yeah, but it's really hard to tank a rocket.
Yeah, cryogenics act a little differently than your typical room temperature fluids.
So 2024 is a huge year for Firefly, and huge for me because I started at Firefly before we had even our current engine model. So before we had any actual flight vehicle, before we had a launch pad, and before any of the things I'm about to talk about even existed, or they were ideas, but they didn't exist. And so 2024 is definitely a year of kind of culmination, which we're very excited about. So up for us this year, we will have Flight 5, which is a NASA VCLS payload, so Venture Class Launch Services. Kind of after that, we will also have a launch of a contract for the NRO. And the kind of very interesting thing for that is it will be on our Elytra on-orbital transfer vehicle. So we'll show on-orbit maneuverability as well as payload deployment with the NRO, so excited for that. Our medium lift launch vehicle, so A330, we are getting ready for a hot fire of a Miranda engine on our completion of TS5. So as we were saying, infrastructure projects, there is nothing that will put a team through their paces like an infrastructure project. And if you want to talk about unsung heroes, it is the GSE design teams. So they're really the people that make the vehicles happen, and they never get any of the credit. So if you're GSE, good for you. So looking forward to that. We have done 3 different tests of our Miranda engine on one of our smaller test stands and then moving it over to do full duration testing on TS5. And I think that I hit all of, I'm sorry, and then Blue Ghost Mission 1. So that is our lunar lander. They just finished the integration of the vehicle, and they're working to culminate their final payload integrations. After that, it will be going out for environmental testing and then looking to launch the end of this year. So very excited to land on the moon.
Right, excellent. Thank you very much for that. I do want to echo one of your things, what you said about GSE. It's basically a rocket in reverse, right? Or an inverted rocket, basically, for probably half the cost on the rocket or something like that. And the effort that goes into that is usually underestimated, and also the work of that goes into that. So
GSE is ground support equipment.
Yeah, sorry.
For those of y'all that don't know, and so all of the items that go into tanking, and we say that it's hard to make something work 10 times, and your poor GSE engineers have to make things that work, hundreds and thousands of times, and if they don't, they definitely catch the blame. So very interesting, and it's the amount of investment that goes into it as well.
All right, I have one last question actually, and it's assume I have magical powers, which I don't have, unfortunately. But just assume that for a moment, and I can grant you one wish. What would you ask me?
Oh, I could start. I'm debating between 2. I think mine would be regulatory. I think that is an upcoming challenge for all of us, namely congestion at the launch sites.
Right.
So if we could make that go away somehow, I think that would
Okay,
be really
that's
great.
interesting. Yeah,
Yeah, I guess if we had one wish, I would go back to the 6-month question, and you could grant the Terran R to be launching in that 6-month period. But so if you have those magical powers, please let me know.
I want to jump over the whole development.
Yes, that's right.
Aside from being able to flip a magical switch and have gravity go away,
That's the one that I expected.
my one wish would be flipping a switch and being at rate. It is something that we are hyper focused on right now with New Glenn and all of our product lines. It's one thing to build one of something. It is an entirely different challenge to build and launch 10, 20, 50, 100 of something in a relatively short period of time. And that's something that we are right in the throngs of focusing on. It's building that machine that builds the machines. It's very much a challenge for any company that's obviously gone through scaling at rate. It's probably, in many ways more difficult to do that than to actually get your first of something done.
And then if I had a magical wand, specifically, I thought about this for a long time. I would like to remove the hazard that is resource protection. So resource protection is if I'm flying from Vandenberg, there's only a certain azimuth that the vehicle can go to because of what you fly over. And so things like that basically would unlock launch from land and launch from different launch sites and different azimuths. And so in terms of deconflicting us from each other, if I don't have to clear because other launchers are launching, if I can do inland launch sites, if I can do whatever orbit that I want to from wherever it happens to be, if I can move to the equator, I think the availability and access to space for us, if all of a sudden resource protection wasn't a thing, I'm not saying that I want to accept casualties, right? But I'm saying if I could just have a little force field, that would be great.
Got it. I did expect a little bit more on the gravity. I can reduce gravity for you too, and not just completely get away. I mean, that would probably be bad, but like go half or go a quarter. But anyways,
just flip the switch right around the area where the rocket has to go.
You would have asked me,
nowhere else, and everything.
Now. Anyways, no more wishes. I want to open it up for questions from the audience, and like some of the other moderators, I can confirm that you have I can see 2 or 3 here raising their hand. Here we go. Okay.
Yeah. Hey, thanks for the great panel. Raphael Rodkin from E2MC Ventures. Question specifically for a gentleman from Blue Origin. So obviously, fingers crossed for your maiden flight later this year, I hope. But you guys also have Blue Ring in-house. And so I was wondering how soon after maiden flight could we see rideshare by Blue Origin?
You mind giving us your name and affiliation?
Raphael Rodkin from E2MC Ventures. Okay.
Yeah, the Blue Ring, not my domain area of expertise. There's not much I can comment on directly. I'm happy to put you in touch with people that potentially could answer that question afterwards. But it is definitely something that we are in active development on right now, and we have a number of critical engineering milestones related to that program that we're planning to pass this year.
Hello, my name is Brennan Swanek. I'm with Voyager Space. So designing a rocket on its own is a feat, but I think it's commonly quoted that manufacturing something like that is 100 times harder. So I was curious if anybody on the panel had any insight in unique manufacturing or novel manufacturing. I'm sure Relativity has something along those regards, but that you could share with everyone here in the crowd.
Yeah, I mean, I can take that. I mean, I think we showed a novel manufacturing capability with Terran 1. Some of that carried over to Terran R, and I think it's proving the way that we can bring Terran R to the market more quickly, especially in the engine side, which I cited. The path to MDC I think was critical. Was a critical technology that we leveraged in Terran 1 that we were able to pass over through Terran R. But it's really all about investing in the infrastructure and the manufacturing now to get Terran R online as quickly as we can, and being able to scale that product once it's available. Mm-hmm.
So you started to touch on a question that I was going to ask, which is about regulations, specifically about launch COLA. When you're launching commercially, you're kind of dependent on the resources of the 19th Space Defense Squadron. As you have more and more cadence and more other folks are launching, are you seeing this as being an impediment, a throttle to your ability to conduct your business? Some questions include, should you even be doing launch COLA except against maybe habitable crewed vehicles? Or do you think that maybe a commercial solution should be offered that allows the Office of Commercial Space Transportation to have some flexibility? I'd like to hear the whole panel's thought on that. Thank you.
Mark, did you have anybody in mind?
All of you.
All of you, not me.
Yeah. I'm sure you have thoughts on it.
I think we definitely don't want to collide with anything when we launch, whether that's crew or uncrew. That's bad for everyone. I certainly don't know exactly how it works with the different regulatory agencies to ensure and where they're getting their data from. If there's more commercial options for more data that we can do those analyses with higher fidelity, I think that's excellent.
I'm not really familiar with the term launch COLA.
Collision avoidance, yeah.
Thank you.
Before you launch, to make sure you're not going to hit something.
Right. Yeah, nothing to comment.
So I am probably intimately familiar because I've done LD for our last 2 missions and LC'd the 2 before. And so one of the things that we've certainly focused on one, I think you should have El-Cola, right? And kind of to echo, if we make more debris, that's certainly not a step in the right direction. I also think there was a change recently where our GNC is now owning more of that process than we used to in our first few flights, but I'd have to look it up to get back to you on that. One of the things that's interesting, though, in the ways that you can improve your access, and I don't think we're quite to a tipping point, right, is the accuracy with which you can hit your kind of T0 and kind of to the homage to the joke about the launch team being ready right on time to be up here. If you run launch or you do things like El-Cola, you know exactly that it really, really matters what moment in that window you're about to hit and how precisely can you time your liftoff. So I think while we can still kind of skate around that and say, I have these windows I can hit in order to get to my orbit, I've got 20 minutes and here's my conjunctions, this is what I'm going to do. I think what we'll see as we continue into this, and you certainly see it as Starlink starts to populate, so you get El-Colas and they'll have multiple Starlink passes in them, is that we will kind of see this run out of the ability to access certain windows diminish as we get more items in space. And so I think, kind of to the point of your question, is before we get to that point of no return where, oh no, all of a sudden I only have 10 seconds and 4 hours accessible to me because of everything that's in space, what do we do to mitigate that? And I don't have a great answer at this time, but I guess that's my opinion, El-Cola.
You're launching, you'll have to go through the 19th. Yeah, if you're all launching at around the same time, you've all got to go through the 19th. They don't have the resources, computer staffing, to be able to provide El-Cola services.
But I guess
they do
and
now.
Again, I'll go
look
at it. But I think that we took on more responsibilities for
this is
this last
commercial
one we did.
commercial launches.
Yeah.
Other national security launches take care of that in a different way.
I think we will deal with that, or they will deal with that basically when they get to the point, and then just because right now we're at the level we're not quite there looking at the Cola except for Megan and Firefly. With regard to that question, do we have any other questions? There was one more, I think, on this side.
Yes, Marcus Harvey. I wanted to go back to the congestion at launch sites. I was interested, what other specific locations would you be interested in launching from? And have you all thought about sea launch? What are your thoughts on that?
Well, I can speak for Stoke. Obviously, we're launching at a LC-14 at the Cape, which is our first launch site. And obviously, the Cape is in high demand as a launch location, due to its low latitude and a lot of sort of existing infrastructure there. I think, yeah, long term, like Megan, we'd love to launch inland. I think you could imagine there's 3 launch sites in the southwest US where you can basically launch to any inclination from any of them and land boosters downrange at your other launch pad. That's a really interesting con-op for that routine logistics that I think we want to all serve. Sea launch can be an option. You have to get a lot of things out there, which can be more challenging. But yeah, I think it will rapidly become the bottleneck in space access, as we'll have a lot of launch vehicles that want to fly at a high cadence, and there will be congestion that has to be solved some way. So it can be time boxing operations. It can be physically moving things far away. I don't really know how we're going to solve that, but it has to happen.
Like Wallops, or have y'all looked at Wallops, or do you have any specific locations outside of the Cape that might be?
We've talked to a lot of the ranges, and yeah, we'd love to launch from multiple locations.
So, and I think in the land of Magic Wand, this is one of those, how do I co-locate all of my production lines? So ideally, I have a production issue, I roll out, I launch, I recover it, and then if I have a problem, I can do it right there. So forgive me that I was using my magic wand when it came to saying that I would change launch sites. I think there was a second half of that question of where would we go, or what was the second half?
I just was interested in other locations besides the Cape. Yeah, I was just interested in what other locations besides the Cape. I know that, like Georgia, they've looked at trying to do things there. I'm just trying to, what other locations would be feasible in the near term for launch? Outside of the Cape, or I think Boca Chica is not, that's owned strictly by SpaceX, but Vandenberg, I'm just trying to think of inland. Where could you launch? New Mexico? I don't know.
I think that it goes back to kind of the issue and like waving the wand, right? So Spaceport America is certainly interested in recovering boosters. Wallops is certainly open, but it's also, you kind of wonder if you didn't go more towards the equator and you kind of get that velocity boost as well. So I don't have one, but I appreciate the follow-up.
And then, likewise for Blue Origin, we're at least initially all in on our launch complex at 36 on the Horn of Cape Canaveral, and there's so much existing infrastructure right there. It just makes sense for, I think, probably the majority of our companies to be there. And for New Glenn, we're building the vehicle less than 6 miles away, and that's kind of a necessity based on the logistics of actually transporting something that large. So for initial launches, we are all in on our facility at Cape Canaveral. At some point in time in the future, there could be a second Blue Origin launch site in Vandenberg, but for right now, it's Florida.
Yeah, I mean, same for Relativity. We're actually neighbors to Stoke there, and it's similar to what Jordan said. We're kind of all in for the initial launches of Terran R out of the Cape, and that's Launch Complex 16, the same launch site that we launched Terran 1 from.
And I would just add to this: not only do you need a launch site, you also need a landing site, either right next to it because you don't want to ferry it, long, or on the other side of the trajectory for the first stage, where nobody should be there primarily. So this is all a really complicated and good question too, especially when rockets get so big that you can't really move them over the street anymore, right?
Yes.
Anyways, I think this wraps it up pretty much. I don't see any more questions. Oh, there's one more over there. Let's make that the last question.
All right. Hello, my name is Michael Barcliffe. I'm an MBA student at the Harvard Business School. So my question is, the panel is just, if you could talk a little bit about Starship and how that's impacted kind of your company's decisions when it comes to like new products and like kind of like where you see the future of like launch.
Who wants to touch that?
I can start. I think from our perspective, it's validation that the inevitable end state is fully reusable rockets. I am very excited every time Starship launches. I'm excited to see them do a fully successful launch and recovery of both stages. I think that'll be great for the market. I think a lot of new business cases will open up, and it is definitely a rising tide, all boats situation in terms of demand. I think that there is absolutely room for medium to heavy lift players in a Starship super heavy lift world. But I do think, in 2040, 2035, there will be this race to the asymptotic cost of propellant to deliver payloads to orbit. And so I think that's what we're designing for.
I think one thing is going to be clear. It's going to be exciting, and we're going to see a lot of changes over the next couple of years, and hopefully new rockets coming online, and also hopefully more payloads, right, and more demands for even more rockets. And I think I want to give our panel here a round of applause for their answers. Thank you. All right, thank you very much. Thank you.
All right. Thank you so much, Hans, and the rest of the panel. That was amazing. It seems like there's a lot of up-and-coming things happening in the near future in the launch industry, so just really excited to see all that happen. So the next session is actually our keynote speaker by Jim Bredenstein. So we'll take a 10-minute break. So if you can be back at 2 o'clock promptly, that would be great. Thank you so much.